everyone, we're going to find the area of the region inside a four-petaled rose and outside the circle. So let's look at this. I put the circle in red and the four-petaled rose in green, and it's just a sketch. What they're looking for is this region in here. So that there's 4 of these. So just quickly do that. That's the area, the region that they want the area for. And the intersections here are at pi divided by 6 and negative pi divided by 6 if we just look at this first region. All right. So what we're going to do is we're going to take the area of the whole curve here and subtract, once we get that area, subtract the area of this region of the circle. So basically the way you're going to set it up is we're going to write the integral from negative pi divided by 6 to pi divided by 6. And then I'm going to write 1/2, using my formula, of 4 cosine of 2 theta squared minus 2 squared d theta. Now that's going to give me this one. So if I multiply this by 4, then this is going to just give me 2. So 4 times 1/2 is just going to be 2. All right. So basically, let's write this as 2, and we're going to get the integral from 0 to pi divided by 6. And I want to only take half of this and then multiply it. So since we have 2, and I'm going to multiply it by another 2, we're going to be at 2 times 2. So again, this was 2, and now I'm only going to do this part of the integral to make it easier. So I'm only going to go from 0 to pi divided by 6 and then multiply it by 2. So technically, we're multiplying it by 8. All right, so that's going to give us 4 here. So we have 4. Now let's simplify all this. This is going to be 16, because this goes away here, 16 cosine squared of theta minus 4 d theta. All right, and the next step is for integration purposes. It's easier to integrate using this trig identity. So I'm going to substitute that in here. So we have 4 integral from 0 to pi divided by 6, and this is 1/2. So 1/2 of 16 is going to be 8. So just dividing that by 2. And then we have 1 plus cosine. And since we have, this should be a 2 here. Since we have a 2 here, this is going to be 4. Because you have to double it up. All right. Minus 4 d theta. All right. Now, let's go ahead and simplify this as 4 times the integral of 0 to pi divided by 6 of 8 plus 8 cosine of 4 theta minus 4. Adding these two up, you're going to get 4. So we're going to have 4 there. So let's move on with that. We're going to have the integral 4 from 0 to pi divided by 6. And we had 4 plus 8 cosine of 4 theta, d theta. At the same time, let's go ahead and multiply through by this 4. So that's going to give me the integral from 0 to pi divided by 6. And now we're going to have 16 plus 32 cosine of 4 theta. You don't have to, but I just went ahead and did it. You could do it later if you wanted to. Okay, so let's integrate. This is going to give me 16 theta plus 8 sine of 4 theta. And then we're evaluating from 0 to pi divided by 6. So we have 16 times pi divided by 6 plus 8 times sine of 4 times pi divided by 6. And with this 0, you're just going to get 0 minus 0. All right, so this is going to turn out to be 8 pi divided by, let's see, where are we getting that? We have 16 pi divided by 6, which is going to be 8 pi divided by 3 for that piece. This is going to be 8 and sine of 2 pi divided by 3. So that's going to be 8 times square root of 3 divided by 2. 2 goes into 8 4 times. So basically our final answer is going to be 8 pi divided by 3 plus 4 square root of 3. And that is your area inside the four-petaled rose and outside the circle. Thank you. Have a nice day. Bye-bye.